Okay, so today we're going to put together a simple assembly. It's going to be about 6 parts, and we're going to create a couple other parts just to finish off the assembly, just to show how you can create parts within an assembly. So this is the assembly we're making right here. It's a little pneumatic single-cylinder engine. This little wheel spins around in the back. There's a little piston that goes up and down as the wheel spins. And we're going to assemble it together in Creo. So first I'm going to select my working directory. I've already navigated to the directory I want to be in, but normally I would have navigated to it. I'm going to hit OK. Okay. Make sure I don't have anything in the background, so I erase not displayed. There's nothing there. So I'm going to hit New, Assembly, MS 1001-00 is the drawing number that I gave to my students. So I'm going to hit OK. And now I'm in my assembly. And it looks just the same as any other part. But first, I'm going to assemble my main piece. Now my main piece looks like, and I'll pull my PDF over, looks like this, a little T-shaped frame where all the other pieces assemble to. So I'll hit assemble. I'll navigate to my T-shaped frame, which is 1001-04. I'll open it up and it'll put it by default in the center. But I still need to define it. Right now it's pink, which means it's not defined. Okay, so what I'm going to do is I'm going to turn on my datum planes, usually a good place to start. And what I like to do is, if these are off, I like to turn on my tree filters to also have my features on. So I can also see my planes and my feature, as well as the different features under my part that I use to create the part as well. So my first starting part, a lot of people, what they like to do is they go up here and they just hit fix. Now I don't like that personally, because it takes a lot of assumptions into play, and I'd rather actually define where my piece is. So we can do this logically. First, I can take my assembly front plane and I can say, okay, I want my assembly front plane to be on the front plane of my part. Now I just selected the two planes, but I'll undo that just to show you the other way you could do it. Is what I could do is, in my model tree, I could select the assembly front, then I could hit this little arrow and I could select the front of my part. All right, and now you can see that those two are on top of each other. So a couple other things that are pretty handy when you're assembling something in an assembly is if you can hold Control and Alt and then middle click like you normally would spin a part, you can kind of see what directions it's constrained in and which ones it's not. So right now I'm on that front plane. You can see that rotating, but I can't move it backwards and forwards. I can only twist it in this one axis, okay, which tells me that I'm kind of constrained in one direction, which makes sense because we only made one constraint. Now if I use the right click instead of the middle click, this is how you can move a piece around without rotating it. You can see it's just moving along this plane. Okay, so if at any point in time you ever get lost and you're not sure of what constraints you have left, that's an easy way to do it. So the other thing I like to do is I like to have this placement open. Now when you're first constraining a part, you can just keep clicking and it'll keep adding more constraints. But if you're editing a part, you have to actually click this new constraint option right here. So if I click new constraint, we'll just get in the habit of doing that. Now what I'm going to do is I'm going to make this right plane of my part and the right plane of the assembly aligned, and this time I'm just going to pick them. I'm not going to use the model tree. I like to move my mouse as little as possible to save a little time. So I'll pick the two right planes. Now those are on top of each other. Now you can see I can't rotate it anymore. I'm holding Control and Alt and the middle mouse button. Nothing happens. But if I hold Control Alt and I use the right mouse button, well, look at that. It can still move up and down. That's why it's still pink right now. Maybe magenta is more accurate. Depends on your definitions of colors. So we're going to go ahead and hit new constraint again, and this time I'm going to take the top plane and I'm going to assemble it to the top plane of my part. Now for my first part, I usually like to use planes because I've modeled the part with the consideration of how other pieces are going to be assembled to it. So if I line my planes up, chances are it's going to put my piece in the right place. But the other thing I could have done is I could have assembled like the top plane to, say, the bottom of my frame. And that would have worked just fine as well. So you can see my part's turned orange now, and that means that it's fully constrained. Very, very important. Also, you get a little clue right here. Where's fully constrained? Your parts need to be fully constrained. Now let me show you what would happen if it wasn't. So if I hit OK now, I'll just middle click, do the same thing. You can see this little white box that shows up. Now what we need to do in that scenario is we need to stop what we're doing right away. We need to edit the definition and add the constraint that's missing. And a lot of times what I'll do, rather than just hunt through the other constraints and try and make sense of it, is I'll hold Control Alt right mouse button, and now I can see it moves up and down. So that would give me a clue that I need my top planes to be assembled. Now I'm going to middle mouse button click again. That's just going to automatically click this check mark. Anything that's blue gets selected by doing that. Okay, you know what, why don't I turn my edges on too? It's a little easier to see that way. Alright, so I go back to my default orientation. Now I have my piece. Now from an assembly, at this point you can use datums or you can use the piece itself. Just to show the other option, I'm going to turn my planes off so we only use the pieces. So I'm going to say assemble. Okay, and what I'm going to assemble first is my wheel. Alright, now my wheel lines up with this hole right here. It has a pin that goes through it. Okay, and we're going to use that hole later to create a piece. But it also assembles to this side, a little space so that we don't have any sort of friction. Okay, so this is where that Control Alt and right mouse button is handy. I can move it over here, and now I have it in front of my piece. All right. Now the reason I did that is if I had just assembled these two middle things, they're going to be right on top of each other. Not the end of the world, but I kind of like to move it out of the way a little bit. So my first constraint is I want this hole, and I can do this a couple different ways. I can turn the axes on and select it, or I can just use the insert constraint, which is just selecting a cylindrical surface and selecting a cylindrical surface that lines up. Okay, and now those are lined up with each other. Now if I use that right mouse button, you can see I can only move it in this direction now. Apologize for the bell. I am a teacher and we do have very loud bells here. So now I can drag this along here because I've already constrained it in two axes, really. I haven't constrained it from a rotation, but Creo does assume that. So my next constraint, so I go to the placement tab, my next constraint is going to be this surface having a distance to this surface. Now you'll see what Creo does, and it's usually pretty good about this if pieces are close together, is it automatically assembled it as coincident. Now I don't want that, so I want distance. Okay, so my distance offset, I'm going to put about 1/8 of an inch here. Okay, leave a little space. Yeah, that might be too much, so why don't we try a 1/16. That looks a little better. Okay, so now that I have a 1/16 of an inch there, and let's say it looked like this. Oops. Let's say I typed that in, it went in the wrong direction. Okay, it would have been as simple as, before the number, just put a negative sign, hit enter. It'll flip the dimension to the other side. This flip actually flips the constraint. Okay, so you can see the part flips back and forth. Now you notice it says allow assumptions right now, and that it's fully constrained. What allow assumptions means is that right now this piece can turn this way. But for most things that you assemble with an insert constraint, for example like a bolt in a bolt hole, you don't care about how it's rotated. If you're assembling things that maybe have like threads or something on there, like modeled threads, which usually isn't the greatest practice, slows down your model a lot. But if you had something where the threads really mattered and you wanted to make those threads line up, well then you would need to have some type of rotate constraint. So if I had that allow assumptions off, you can see it's orange now. very easy to fix. Okay, I could say, for example, well, you know, new constraint, this plane needs to be oriented in the same way as this plane right down the middle. Okay, and I could say they're parallel. All right, well, now it's fully constrained as well. So I can either use allow assumptions or do it that way. Both do the same thing. So I'm going to say okay. Now I've got my other piece assembled here. Okay, now the third piece that I'm going to do is I'm going to assemble the 2 feet on the bottom here, give us a little stability. So if I hit assemble, and part number 3 is the feet. Okay, now the way that my feet are assembled here is there's a little bolt that comes through the front, okay, and assembles through into this piece here. So my first constraint that jumps out at me is that this hole right here needs to line up with this hole. All right, now I can see that went the wrong direction, right? But I also need to look at what I have. So I can see this surface here is all the way back. So it's actually assembled in the right direction. It just doesn't have all of the constraints I need. So I'll turn my datum planes off, make it a little easier to see. I'll add a new constraint by saying this surface is going to assemble to this one. And then you can see because they're further away, Creo assumes, well, you know, maybe they want a distance. This is really, really far apart. But I can just hit my pull down here and go to coincident. What you should not do not do this, okay? There's a lot of people who design things and they do this way, which is very terrible practice, really, really bad, is type 0 and hit enter. Now you may think, well, it does the same thing. What does it matter? Well, the issue is Creo is a parametric modeling program, okay? So all of these little dimensions, these little constraints, all this stuff is part of the parameters. So when you put little zeros in here, number one, you can get some really weird results down the road when you go to redefine this thing. But more importantly, every single number gets recalculated every time you open the part and when it's not in session. So you're better off just hitting coincident, because then they just understand that those two surfaces meet up now. Okay. Now I'm going to turn that allow assumptions back on, because normally you should have that on. All right, but you can see mine can go like this right now. So if I was really worried about that, I could have that off, and I could say, well, these two surfaces are parallel. Okay, and that would orient it in the right way. All right, so that one's okay. Now, if I open up this part, actually I don't even need to, I can just hit this little arrow here. I'll notice that these holes here were patterned. So normally what I could do is I could do a little reference pattern that would jump it over to the other side. The problem with that is since I also patterned this hole up here, that's the same size, if I was to pattern it, it'd create feet all the way through all three of those. I can get around that though. So if I hit pattern, you can see there's my 3 dots, right? So if I hit OK now, well, I've got the foot on the other side, but I didn't really want it there. So in my pattern, I can just turn off this dot, and then I can hit OK, and now I've only got those 2. All right, now one thing to remember with a reference pattern, and the reason that works is because it's a reference pattern, it's referencing an initial pattern. Now you also have to notice which one of these circles has another little skinny circle around it. Okay, that is your initial instance. You cannot turn this one off. I can turn this one off. I cannot turn this one off. Okay, so that's important to recognize, because if the initial pattern is the one that you don't want, then you won't be able to use that reference pattern, or you'll have to go back and edit your feature. The reason that's my initial one is because that's the first hole I made on that feature. Okay, so now I've got those 2 feet in there. All right, and if we work our way down, our next piece is a little crank plate, okay, that sits back here and rotates around to give some movement or create a rotary motion of the piston that goes up and down. Okay, so here it's kind of hard to see, but here's a little guy right back here in between these 2 parts. Okay, so I'll go to assemble, All right, and I'll go ahead and open part number 5. And there's my little crank plate. Okay, so my first assembly constraint is going to be that this assembles to this. Okay, if I move that in, look at that, it lines right up. Now, for my next assembly constraint, I'm going to say that this surface and this surface have a very small amount of space in between them. Okay, very, very small amount of space. Okay, now I could put that right up against there. Really isn't a big deal if I was to do that, because there's plenty of space here for this little guy to move around if it needs to. Now the other constraint I'm going to apply is I'm going to add another constraint to say that I want this surface and this surface to be parallel. Okay, now I could also change angle offset, and then I could start typing in numbers, and I could rotate this thing around, right? But for now, I'm just going to make them parallel. I can go back and edit that later if I need to. All right, so now those pieces are all lined up. And the next thing I need to do is I need to assemble part number 2, okay, which is my cylinder. All right, so the way my cylinder works is this hole lines up with this threaded hole. Okay, and that's where it rotates around. I have a little bushing I'm going to assemble that rotates around. Okay, now the other thing that matters here is that this right here rotates with the bottom pin here, because there's a little piston that moves around. Now we're not going to model that piston because this is just a simple assembly that we're just getting used to how to assemble pieces. But if I modeled that, then I probably would have assembled the piston first and then assembled it into this bore. But the interest of saving time, I'm going to say that this surface and this surface are parallel. Okay, so they line up. Now the last thing I need to do is this thing pretty much sits right up against this surface here. So I'm going to pick these 2 surfaces, and I'm going to say they're coincident. Okay. Now I have that feature assembled, and then the last feature I have of the 6 parts that the students need to create is this little bushing. This bushing goes right in here, and that surface sits right up against there. It's coincident. All right, and for that one, I don't care how this thing's rotated. It's completely symmetric radially, so I'm going to allow assumptions on there. All right. Now, normally what would happen is we'd have a little bolt that assembles through there into this piece. Okay. Now, in the interest of saving time and keeping this video short, what we're going to do is we're going to create the pin that goes from this side and assembles over to this side. Okay. Now the first thing I'm going to do is I need to know how long that pin is. So I can go to Analysis, Measure, hover over this surface. Gives me a whole bunch of information. Hold Control and pick the other surface. Now it's telling me that it's 0.873 long. Okay, so that's awfully close to 7/8. All right, so maybe what I'll do is I'll create a pin that's 7/8, and it'll just sit flush with here and maybe stick out a little bit on the back of that one. Okay, so here's how you create a model within an assembly. Now, the first thing I'm going to do is I'm going to say create a component in assembly mode. You see that message right there. And it's going to give me this create component. Okay, now what I'll call this thing is dowel pin. Okay, and I'll hit OK. Now it says, do I want to copy from some existing stuff? Do I want to locate datum planes, things like that? And what I'm going to say is that I want to locate some default datum planes, and I'm going to say, oops, sorry, jumped the gun. I want to locate default datum planes, and I'm going to hit OK. Okay. Now, what I need to do is turn on some datum planes. All right. I think it accidentally backed me out of there. All right. So let's try that again. Delp in. And you know what? Why don't I just hit create features? That's another way I can do it. Okay. So now I'm in create features. I'm creating my dowel pin. You can see there's a little green star there. I'm going to say I want to create a revolve. And I want to create that revolve on this plane that goes right down the middle. It's going to zoom me in. Now for my references, I'm going to turn on some axes. Okay. And for my references, I'm going to say I want this axis right down the middle of this hole. I want this surface over here, and I want this surface over here. Then I'll middle click a few times so it goes away. And now just like I'm creating a normal revolve, I want a center line, and then this dowel pin's going to be round, so I'm going to make a little rectangular section. Now what I could do is I could go right up to this length here, but I'm just going to do that just so I get a dimension here. So I'll say it's 0.875. All right. Now, if I had turned this to have hidden lines, oops, missed it. Hidden lines. The other thing I could do to make sure this dowel pin's the right size is I could say this line is in line with that hole there. Okay. Now, I don't even have a diameter on this thing. Now it is 1/8 of an inch because that's how big that hole is. But now I can hit my checkbox. I'll turn my shading back on, and you can see there is my dowel pin. All right, rotating around. I'll hit my checkbox. Maybe I want to throw a few chamfers on here. Make it 45 degrees by, I don't know, 0.01 is fine. Hit OK. Now I've got a little dowel pin in there. Now to go back to my assembly, all I need to do is right click my assembly and hit activate. Now my dowel pin's not saved yet. It's there. We can see it in the hole. However, it does not save until I hit save up here. Save object pops up. I hit OK. Now if I go and hit open, okay, look at that. There's my dowel pin. I can open them right up. All right, modify it as much or as little as I like. All right, and that's how we assemble this together. So we use a couple different constraints. Okay, we use some datums, use surfaces. Surfaces tend to be the best once you have a base component. The reason I like them personally is because now if I move any of these holes, for example, if I open my frame up and I change my design and I say, well, you know, this actually needs to be not quite that much, but this actually needs to be 2 3/4 up here. I regenerate this, I close it, you can see my holes moved. I regenerate my assembly, look at that, everything moved with it. Okay, so it can be a little bit of an advantage. If you model things properly, it really shouldn't matter either way. Okay, if you spend some time paying attention to how am I modeling this, what's the orientation. Notice the orientation of this part when I modeled it, it's exactly the same as it was in the assembly. And considerations like that can save you a lot of time down the road. Okay, so I'll put up another video. Gotta regenerate my model. I'll put up another video about making a drawing for this, but that's how you assemble a simple assembly. This is 6 parts, well 7 now. I guess 8 if you want to count these as 2 different parts, but they're 7 different parts, one of which we created in the assembly. Okay.